Welcome to another tutorial for the Magic Markers asset for Unity. In this video, we'll demonstrate how to create magic markers to represent objects in your project, how to customize the appearance of marker types, and how to add your magic markers to Unity GameObjects in the scene. We will learn about the Magic Marker Inspector properties and how to customize the marker's behavior in the Unity editor and in your runtime build. Everything in this video can be done with no coding, using only the Unity editor's dialogues and the Magic Marker's custom inspectors. Advanced topics, including writing custom Magic Marker subclasses and controlling Magic Markers from C# code, are left for other tutorials, or you can refer to the Magic Markers user manual and the Quick Start guide. If you haven't yet watched the Magic Markers introduction video and tried out the demo scene, please do so now. For this video, we will begin with the Unity project from the introduction with Magic Markers already installed and working. Let's create a new empty scene directly beneath the Assets folder so we can learn Magic Markers without disturbing the demo scenes. We'll call the scene Magic Markers Test 01, and let's save it now so we don't forget. You may also want to open the lighting window for your scene and set everything to real-time mode and disable the automatic light map baking, which I've done off camera here. For the sake of organization, let's also create a folder called Marker Types. This is where we will put the asset files that define all the custom magic markers we create for this very small project. It's a good idea to keep your own custom marker type assets separate from the Magic Markers plugin folders. That way, you won't accidentally lose them or overwrite them if you upgrade Magic Markers to a new version. Magic Markers does not care where these files are located as long as they are inside your project view, so in a real project you can organize marker types in the same way you prefer to organize other assets such as models, materials, and media clips. We'll make another folder called Prefabs, which we'll use later. For now, it stays empty. Before we start working with Magic Markers, we'll need a convenient surface to showcase the markers we create. Let's just grab a duplicate of the Unity terrain from the Magic Markers demo scene. With our empty scene open, just navigate the project view to Plugins, Magic Markers, Demo, Scenes. You'll find a prefab called Magic Markers Terrain. Just drag and drop this prefab into your empty scene. Select the new terrain in the scene view and use the inspector to make sure its transform is set to the 0 point. While we are setting up the scene, let's also borrow the camera rig from the demo scene, since camera control is not part of this tutorial. Just drop the prefab into the scene, then use its inspector to set its transform to 20, 0, 20, which is the center of the terrain. The camera prefab has its own included main camera, so delete the one Unity provided by default to avoid conflict. Save the scene once again, and we have a nice test environment. Enter play mode briefly to make sure things are working. Let's get started with our first magic marker. As you have seen, there are a raft of pre-made examples included with the asset, but let's pretend this is a real project and make our own from scratch. This will give us a chance to explore a realistic workflow, and it avoids changing any of the pre-made markers from the demo scenes. Each magic marker is a component, specifically a C# mono behavior script, attached to a game object in your scene in the usual way. Just as a mesh renderer obtains its geometry and other properties from a mesh asset, so Magic Markers obtain their geometry and properties from a custom asset file called a Magic Marker type. These are very small files that we create in the project view, and like other assets, they can be copied from one project to another. Of course, you can simply copy an existing Magic Marker type asset using the Unity clipboard or the duplication keyboard command. But for this exercise, we will use the menu to create a new one directly in our folder. Generally speaking, Magic Marker type assets should represent a marker's purpose in your project rather than being thought of as representing a shape. This is because the Magic Marker type controls not only the shape, but also the default color, transparency, and several other properties of its markers. You will probably have several different uses for each of the predefined shapes, especially in a large project, so name your magic marker type assets accordingly. In our example project, we'll need a place for our player object to spawn. One of the predefined shapes, called a booth marker, is often used for spawn points, so let's create a spawn marker type with that shape. By the way, we're going to do this first marker the long way so you understand how the parts work, but don't worry, we'll introduce a faster method later in this video. In Project View, navigate to the empty Marker Types folder you created earlier. Now, use the right mouse button to open the context menu and choose Create, Magic Marker, Booth. Let's name our new asset Player Spawn Marker. Congratulations, you have just created a new magic marker type. Select your magic marker type and look at its inspector. If you renamed the asset file as you created it, then the name of the file will also be the default for its display name here in the inspector. You can change the display name and help text to whatever you like. It doesn't have to match the file name. That is just a convenient default. Remember that the asset file we just created is not a magic marker. It contains the properties of a type of marker, in this case a player spawn marker. Now let's see how our marker type looks in the scene. There are several ways to create a marker game object. We will start with a very basic method and then see how to do it more efficiently later. In the hierarchy, with no game object selected, use the right mouse button to open the context menu. Choose Magic Marker, Create Empty. This will give us a game object in the scene with the magic marker component pre-attached. The game object will be invisible and will probably be at the 0 point of the scene on one corner of your terrain. Drag it in the horizontal plane over to the approximate center of the terrain. For now, we'll place it on the blue river because that is a convenient flat surface. Our magic marker is invisible because we have not yet told it what shape it should be, but we can fix that easily. With your magic marker game object selected in the inspector, notice the marker type field in the magic marker component. You may also notice that the fold-out panel below is disabled, and it says the marker type is unknown. From the project view, drag the player spawn marker asset file you just created and drop it into the marker type field of the component. Behold, one lovely green booth marker ready to indicate your player spawn points in your scenes. Zoom your scene view down close so you can see your spawn marker clearly, and let's customize it a bit. Start by clicking the little arrow next to the blue text that says Player Spawn Marker. This will open the fold-out panel, which you'll notice is exactly the same as the inspector for the asset file we created. They don't just look similar, they literally are the same, and the version in this fold-out area is just a shortcut to save you from having to locate the original asset file in your project view. The inspector you see now is a combined inspector. Everything above the blue marker type text applies to this specific marker only and optionally to its prefab, while everything below the blue text applies to all markers of this type in your entire project. Let's illustrate this with a simple test. Select your spawn marker in the scene view and press Ctrl-D or Command-D to duplicate it. Now drag the duplicate a little to one side so you can see both. Now do it again so we have three of them near one another. From the inspector of any of the three, open the blue fold-out area. Below the blue text, click on the primary color selector and drag the mouse to change the main color of the player spawn marker type. All three markers of this type within the scene are affected because we have changed the asset file from which they obtain their properties. Now look at the area above the blue text on one of the three markers. There is also a primary color field there, but it applies only to that one marker object and not the general type. By default, this local primary color is set to clear, that is, a value of 0 for red, green, blue, and alpha channels. Unity shows this as black in the inspector, but the 0 alpha makes it fully transparent. If the local primary color is clear, with RGBA values all exactly 0, magic markers will ignore the local setting and show the marker with the default primary color for its type, Click on the local primary color setting, the one above the blue fold-out text, and change its color. If you forget to make the alpha non-zero, your marker will become invisible, which is probably not what you want. Choose a color you like, drag the alpha slider to about midway, and save the change. We'll make this one a semi-transparent blue. The new color should show on the one marker you edited, but not on the others. Now look below the blue fold-out label and select the primary color field for the marker type. This field will change the color for all of our player spawn markers, not just in this scene but throughout the entire project. Let's make the marker type completely black but still somewhat transparent and observe what happens in the scene. Are you surprised? It appears we changed all the markers except the one we are inspecting. If you think about it though, you'll understand why. We have changed the primary color for the player spawn marker asset file, which alters the marker type, but this specific game object we are inspecting has a non-clear value for its local primary color setting, so this one ignores any changes we make to the primary color of the underlying marker type. Open the primary color for the marker type once again, that is, below the blue fold-out text, and drag the color value around a bit while observing the markers in the scene. As we just explained, the primary color for two of the markers changes, but the third one does not. However, look closely at the little pointer in front of the markers. As we change the primary color, the pointer, which is automatically drawn in the secondary color, changes as well. That is because, by default, magic markers compute their secondary color by inverting the primary color. In other words, the automatic secondary color is an RGB value of 1 minus the primary red, 1 minus the primary green, and 1 minus the primary blue, respectively. The alpha channel is not inverted, however, but simply copied from the primary to the automatically generated secondary color. So why is the secondary color changing for all three of our markers, while the primary changes only for the two that do not have a custom primary color? The answer is that all three markers are still of the player spawn marker type, and that type has a checkbox indicating that the secondary color should be automatically computed. We overrode the primary color in one marker, but its secondary color is still clear, so the default prevails. We could change this very simply by also overriding the local secondary color and setting it to whatever we like. Suppose we decide not to override the color in one marker anymore. To easily return it to its default, just click the Clear button next to the local primary color field. The marker will quickly return to the default color, though there may be a slight lag because of the way Unity's scene view performs screen updates. Green is a sensible color for a player spawn point, so let's edit the marker type's primary color and set it back to the original value, but let's do it a different way. Instead of editing in the combined inspector, this time let's locate the player spawn marker asset file and inspect it. Change the primary color there, and notice how all three markers in the scene change color right away. This shows that the markers really are controlled by the properties in that asset file. Having proven our point, let's select one of the markers in the scene again and return to the combined inspector, which is the one you'll want to use most of the time. Let's customize these spawn markers a little more. They are three-dimensional objects, but they don't look very three-dimensional right now because we can't see the edges. In the marker type settings, there is a drop-down option to choose the highlight mode. Click on that drop-down and choose Edge Lines. Now our markers have thin lines along important edges to help us see that they are three-dimensional. The Edge Lines feature only works in scene view, not in the game. For markers that will be seen in the game at runtime, or if you choose to turn off the highlighting feature, the Fresnel Faces option slightly accents the edges and corners of the marker to make it appear more three-dimensional. Another option for highlighting is the wireframe mode. This relies on a geometry shader, which is only supported in Shader Model 4 and higher. It works in Windows DX11 and higher, as well as recent OpenGL versions, but not on some other platforms. The advantages of wireframe mode are that it is rendered by the shader, which means better performance, and that it works in the editor and at runtime. Unlike Edge Lines mode, however, wireframe mode draws the edges of every triangle, which may appear visually cluttered. Our player spawn marker is now ready to use, so let's use it as a pattern to make an enemy spawn marker that is red instead of green. Navigate to your marker types folder, select the player spawn marker asset file, and press Ctrl D or Command D to duplicate it. Name the new one enemy spawn marker. Select the new asset file in the inspector and change its display name appropriately. Now edit its primary color to a bright red. For the enemy marker, let's turn off automatic secondary color and override the setting, making it bright yellow. Return to the hierarchy and make sure no objects are selected. Once again, open the GameObject context menu and choose Magic Marker Create Empty. Drop the new enemy spawn marker asset into the marker type field, and then drag the finished marker over to the middle of the scene for a better view. We now have distinct magic marker types for player and enemy spawn points. Now we will create another marker type. Let's make a marker that would be suitable for an in-game quest target visible to the player. Return to your marker types folder in the project view and open the Create menu with the right mouse button. Again, choose Magic Marker, and this time we will use the diamond shape. Name the new asset file Quest Target Marker in the project view and set its display name to Quest Target in the inspector. Before we customize this marker's appearance, let's put one into our scene so we can see the changes in real time. This time, instead of creating an empty marker and assigning it the asset file, we instead will use the Magic Marker wizard. In the hierarchy view, be sure you have no GameObject selected. Now open the context menu and choose Magic Marker, then Create with the ellipsis. This opens the Magic Marker wizard. Now we see a selection option to choose the marker type. Open this selector, and there is the quest target as an option. We didn't have to add it to the list because Magic Markers automatically finds all available marker type assets in the project. Pick the quest target from the list, and it appears in our scene. If we had selected an object before opening the wizard would have offered us the option to add the Magic Marker component to the selected object or to create a child object with the marker attached to that child. Since we deliberately had nothing selected this time, that option was not applicable, so the wizard skipped it. Double-click the new object in the hierarchy to show it in the scene view and the inspector. Again, it's likely at the corner of our terrain. Before moving it, let's use the inspector to switch on the Ground in Editor option. Now drag the marker over to a convenient spot on the terrain, noticing that it follows the ground contour. There are limits to this grounding behavior, but it works well on typical terrain contours. Now we can customize the quest target marker while observing it in its native habitat, on the terrain. Since we plan to create these throughout our hypothetical project, we will customize both the marker type and the marker instance, and then we will create a prefab from the finished marker. Open the fold-out marker type inspector so we can see all of the settings in the combined inspector. Remember that everything below the fold-out label, that is, below the blue text, is for the marker type, while everything above that label is for this marker and the prefab we will make for it. Let's start by changing the color. Pick a color that you like, such as this bright yellow. You've already seen that the secondary mesh, in this case that circle at the base, is automatically adjusted to blue because that is the maximum contrast from yellow. We plan to show this marker to the player in-game, so the edge lines highlighting mode will not help. Instead, this time choose the wireframe mode. Initially, you can see that nothing changes. That is because the thickness of the wireframe defaults to 0. To create a bold effect, drag the wireframe thickness slider well toward the center, making a nice thick line that will render in the editor and in the game. We should also leave Fresnel faces enabled to make the marker look as three-dimensional as possible even on platforms that don't support the wireframe shader. By default, the diamond marker is only 1 meter tall, and it's sitting on the ground. For our quest target, we will change both of those things. The scale is not set in the marker type, but rather in the marker instance properties above. Resist the temptation to use the GameObject's transform to scale a magic marker. Instead, use the primary scale slider in the marker's own inspector. Magic markers are designed to scale separately from the rest of their GameObject because of their special purpose as metagame objects. Move the slider until you like the size of the marker. We'll go with a scale of 2.0 here, and let's use the numeric field beside the slider to set that exact value. The elevation off the ground can and should be set in the marker type inspector, so we will do that next. To avoid having the player walk through the marker in the game, and to make it visible from further away in outdoor scenes, we can elevate it by 3 meters in the y-axis. Now, we don't want the secondary mesh at all in this case. In some cases, an easy way to get rid of it is to make it transparent by turning off the Auto Secondary Color option, then setting the secondary color's alpha value to 0. In this case, though, we are using the wireframe highlighting mode, and we need the secondary color to be visible, so the invisibility option will not work here. Fear not, there is another way. Returning to the marker instance settings, use the secondary scale slider to make it as small as possible. The minimum value is non-zero, but still pretty small. Finally, in the marker type inspector, we can use the secondary offset's Y value to bury that unwanted disk deep underground. We will set it to -5 meters, which should be plenty even for fairly steep terrains. You can set yours to -100 meters or even more if you really want to be sure. Drag your marker around the terrain a little and observe that the grounding feature still works as we would like, with the marker floating nicely 3 meters above the ground contour. The offsets and scales only affect the visible features, not the actual marker origin point. Something else we should tweak is the secondary color. It looks all right, but since the main color is slightly transparent, the highlights are not quite as bold as we would like. Turn off the auto secondary feature and set the alpha value of the secondary color to maximum, making the highlight fully opaque. You may find this helpful with some of the other marker types because typically the secondary features are a lot smaller than the primary. We are almost done. All that remains is to make the marker work in the game as well as in the editor. Enable the Draw in Game checkbox for the marker instance, and a camera selection option appears next to it. By default, no cameras are selected, so fix that by choosing Everything from the list. Magic Markers allows you to select specific cameras from your scene to include or exclude. You can also select cameras by generic categories, such as whether they are the main camera, or whether their viewport is full or partial screen. The Categories feature is useful for marker prefabs that may be used in multiple scenes, because in that case you cannot list specific cameras ahead of time. Press play, then use the arrow keys or mouse to look around the scene and see that the quest marker works in the game view. Notice also that the green and red spawn markers are invisible in the game as we intended. Then stop play mode. Lastly, we need to create a prefab for the quest marker, something you probably already know how to do. Just drag the GameObject into that prefabs folder we created earlier, and you have a prefab. As a final test, drag and drop a few additional instances of the quest target prefab into your scene. They each have the auto-grounding settings, so no matter where you drop them on the terrain, they will snap to the correct height automatically. This is the basic process for making custom magic markers for your project. Just repeat the process whenever you need a new marker type, and remember that you can use the same shape for many different marker types with different colors and other visuals to tell them apart. Be sure to choose a different display name for every marker type asset you create so that they will be distinct from one another in the wizard menu. If 2 or more of your markers have the same display name, Magic Markers will show a warning in the wizard to let you know that some of your marker types are not available from that menu, but otherwise there is no harm done. This concludes our Magic Markers tutorial. Thank you for using Magic Markers.